All right, so let's do a couple more problems. So number 66, we're gonna sketch f of x equals x squared minus 4 over x plus 2. And we're gonna take the limit as x approaches -2 of f of x, okay? So now, if you took college algebra last semester or in the summer, then I know that you've done something like this. You remember exactly what I said, especially if you took it with me, to do with something like this, right? You looked at this and you said, uh-oh, there's a division by zero problem at x equals -2, right? And you said, well, we can write this as x minus 2 if x is not equal to -2, and it's undefined if x equals -2. Okay, and from there you can graph this. Okay, we can graph this quite easily. So at -2, we're going to have a hole. The hole would be -2, -4. And then other than that, it's going to be a straight line. Let me just, okay. Right? So now, what would be the limit as x approaches -2? Well, as x approaches -2, you're going to come in from both sides, and it's just going to be equaling -4. Right? We called that a hole. Okay. Let's do another one. Let's do 72. We're going to same thing, sketch and find the indicated limit. So our f of x here, we're going to have, remember what we deal, or sorry, we're going to have a piecewise defined function. So it's 2x plus 4 if x is greater than 2, and 2x squared if x is less than or equal to 2. And we're going to indicate, we're going to find the limit as x approaches 2 of f of x. Okay, so we play our drawing game. At 2 is where things change. So I'm going to start from 2 and work my way out. Okay, so x equals 2. Just drawing a little very sort of should be a little bit more faded. Let's try that again. Very sort of gentle line. Okay. Became less gentle as I went down farther. There we go. Okay, so now, when x is bigger than 2, I have 2x plus 4. So I'm going to go ahead and start. What happens here when I plug in 2? If I plug 2 in here, I'm going to get 4 plus 4 is 8. So I'm going to go up to 8. And I'm going to draw this as an open circle. Okay. Just know that it's going to slope up 2, so I know it's going to look like so on the right. Now on the left, it's going to be a quadratic, right? Again, I'm going to plug in. What happens here when I plug in 2? Oh, 2 times 4 is 8. So that's going to fill in the circle. Okay. So this limit does exist. Limit as x approaches 2 of f of x equals 8. You got the same thing. You got the same thing on both sides. So this limit does exist. Okay. Could have easily gotten one that didn't exist. Let's do one very similar. Let's call it 72 prime. Okay. And let's take f of x equals, instead of 2x plus 4, let's take x plus 4 if x is bigger than 2. And let's keep that 2x squared if x is less than or equal to 2. Okay, let's make this all a little bit smaller. Or actually, we can do it like this. Do it like that. There we go. Okay. I'm going to graph a little bit. So x plus 4, again, 2 is our break point. 2 is where things happen, okay, where it changes shape, okay? So at x equals 2 on the, well, let me draw that in, the gentle line, just to indicate that's where things are happening. On the right, when x equals 2, I'm going to get 6. I'm going to do that with a open circle. Let me erase the open circle. And then I have a line sloping up again. Okay, 2x squared though is doing the same thing it was doing before. So that point is 2, 8, and we're going to have the same thing we were doing before. Okay, so now, oh, I should have an, nope, that one's closed. Okay, so the limit as x approaches 2 of f of x does not exist. Okay, just like before, we'll take a look. Limit as x approaches 2 from the left of f of x. From the left, it's going to equal 8. From the right, it's going to equal 6. And f of 2, in this case, it's defined by the left-hand side with the equal to. So it's going to equal 8. Okay? All right. I think that's it for 10.1. No, I don't think that's it for 10.1 that I have for you. I'll see you all in the next video.